Welcome to another GCBASIC demonstration and video. Please like and subscribe. These numbers are so important, honestly. They're not great, but it's just like and subscribe. This is Blockly Update 3. Let's get straight into it. Let's not look about. So the URL is gcbasic.com and then it's uppercase gcbasic underscore blockly.html. The question mark DL equals 1, just make sure you get the latest version. Let me just take that and click it. So it will take you into something that looks like this. It will actually look more like this when you first go in. So I'll zoom in on that just to give you. It will look more like this. It will have this README file showing to you. Every time there's a version change, you will get this, so it keeps you up to date. So in the top, you've got some URLs, which we will come back to. But essentially, you can see the build number inside of the version and what was implemented on that particular time. This is the 17th of June, and I have implemented tabbed user interface. So let's have a look at tabbed user interface on a browser that I just opened. I'm going to leave that there. Okay, so let me just zoom out. It opens to something as complex as this. Now, this is showing you the full set of capabilities that you've actually got available, and that includes setup, creation of constants, logic, maths, loops, text, lists, subroutines, lots of commands and containers. But what I'm going to show you is just the quick stuff on how to get operational. Now, what is different about this user interface is that the system log is at the bottom, and it says grid toggled off, XML loaded successfully. I will show you that by zooming in on the bottom. Let me just crank, there it is, look. Grid toggled off, XML loaded successfully. Now, on Safari, you may have an issue. Just toggle the grid off and it will fix it. Okay, but zoom out. What I'm going to do is clear down the workspace. I'm going to reset the workspace. Say OK. It's now an empty workspace. It still shows the logo, and after a few seconds, it just disappears, which is fantastic. Let's get started. So recently, I've added the README, and in the README, there is another option in there that you need to take, and it says See Example Guide. See the example guide, and it will take you to a page of examples that I've posted. It's not a fully comprehensive list of demos, but it's a good place to start if you just want to kick the tires to see what actually happens. So this is a series of them. Actually, there's some pictures in the folders as well, but you can't get to them. Let's just look at this one, Robot Controller. If I double click it or click it, it will open up Blockly. I'll zoom out. It may open this because I actually haven't said OK on this yet. So I say OK. And it's opened up a set of capabilities. And if we look around these capabilities by zooming in, we can see on the left it says a robot controller, explanation of the program. You can click on that. You can expand the block lot, and it's got a full explanation of how this program works. So you can put comments in now, etc. Collapse that block. It doesn't generate code. If it's in grey, it doesn't generate code. It has to be a particular type of comment to get into your code, and that's called a remark. And in our program, we have got, I'll collapse that blocks for you, a very simple program. It says, let's start at the robot logic, declare some variables, and there's a do loop, which measures the distance and makes some decisions. Select chip, we've seen that before, and it will work on any of the chips. Over here, we've got a group of constants. I'll expand that block, and that set of constants controls the motors. It controls this little robot, and it's got a trig port, an echo port, 4 motor controllers, some timeout values, speed of sound, and safe distance. And you can use those constants now within the program, within the Blockly solution. So if we can assume they're there, I can then collapse it. Let's look in our do loop. What's changed is you can consume these constants. So if we look at this, it's got a comment called measure distance, and it calls a subroutine called measure distance. And if we look at that carefully, I'll zoom in closer so you can see it. Measure distance. It's a call subroutine. And if we look here over here, we have a subroutine called measure distance. I will just open that up for us so we can expand that block. And here is the whole block. And it says things like clear the trigger. That's a comment. It sets the trig, and that's a constant to off. Therefore, that must be a port. Has a wait, a comment. Don't know what's tucked up behind there. Something tucked up behind there. Oh no, that was the other one that was tucked up. I'll just put that back because we're looking at this subroutine here. Sets the constant to on, and then it waits 10 milliseconds, and it's 10 US. It's just it's essentially going to measure this this trigger sign signal. It measures the pulse by setting a pulse width to 0, and then it's got a logic statement. This has been changed. This is now the implemented version, and in here we're saying do while the echo is equal to 0. That means the echo port is still low, and the pulse width variable, I've used the word variable, is less than the timeout. So it will stay in this green do loop for a period of time, and it will increment pulse width by 1. It says here, pulse width equals a calculation of pulse width plus 1. And it will therefore stay in. So what we're seeing here are two different things implemented most recently. You can set a constant, and if it's a port, it will allow you to set it to on or off. That's high or low, 1 or 0, you call it what you like. And you can consume a value like timeout into your program. And the rest of this program, the rest of this piece of code is the other piece of measuring the signal. Let me zoom up a little bit. There we go. I'll just resync the screen for us. There we go. It now says set it to 0, and it's got a do while something. Let's expand that do while, and it's a very similar do while. So we've got a do while, we've got a logic statement, we've got an echo equals 1, which means that the echo port is now high and it hasn't timed out. Then we do some calculations and we return that value back to our program. It's very simple. But what we're now saying is quite complex programs. And what you can now do, which is different in the user interface, if I cursor up, move to the top of the program on my browser to make sure you can see it. There we go. If I say generate code, rather than having to look down the bottom, new tab, you've got a tab here called GCBASIC output, and it's now got the generated output shown on the screen. So I'm just going to move my screen about so we can have a look at that. There we go. We can now look in here. We can scroll through the program, and this is the subroutine we're looking at. It's generated code that says, here's a subroutine. It clears the trigger, waits 2 microseconds, sends a 10-second pulse, measures it exactly, do while echo equals 0, and the pulse width is less than the timeout. That's exactly what we saw in Blockly, and if we take this code, it will compile. There is absolutely no doubt it will compile because it will. I can't say any more than that. So essentially what we've got is a different user interface in this version now. We've now got this tabbed view, so you can generate your code, make changes, and you can see it directly in the tab. You don't have to hunt around the bottom in the window. In the bottom, you've still got the system tab, the system log. I'll just zoom out so you can see that. You've still got the system log at the bottom. It's still churning out little bits of stuff. Might be useful. I might delete it later. I'll wait and see if we need it. But essentially, what we've now got working solutions. So I can now go back into my README. I can look at the example guide, and I can pull up Hello World to LCD just by clicking it. It will take me in, and this is sets up the LCD for I/O 4 ports through a standard set of constants displays a string called hello world, end of program. Let's prove that by generating the code, and we'll look at the code by taking the tab, zoom in on that, and it says here, it selected the chip. We'll have a look at how it's done that. It's selected the constants. We'll look at how it's done that. And then it says, miraculously, display a string, hello world. And it will work. How's it done that? It's done that over in Blockly. Let's look at the Blockly source. In the Blockly source, here we go. I'll zoom out. So where did it get the constants from? It got them from the constant block. And in the constant block, if I expand that, there's a block of constants. And they don't have to be in blocks, by the way. They just happen to be in blocks for me on my solution here. And you can have them wherever you like. It doesn't really matter. And I can sort of move that about. That's a block of constants that I took directly from the help file. Just imported it. And these are all set up for, and so therefore you can use them. I selected the chip, and there's a huge drop-down menu of chips there. And this is the comment. Spoke about this a little while ago. This comment has a little hook on it, and that is a rem. If there is no hook on it, it's just a box. It's decorative text. And that is the full extent of the program. You can select the chip, hangs in free space effectively. And then if you want a program that says display string, hello world, job done. If you wanted to put that in a container so you can compress it, you can pull a snippet out and just hang that all in a snippet. And then my program, give it a name, and we'll look at what that's done in the source. And so therefore you could create little snippets of code. I can collapse that snippet in my program. But let me just generate the program, and we'll look at what it's done. GCBASIC output. I'll zoom in. Same header, effectively the same header, but in the source it says my program, which is actually the little comment we put on the container. Display string hello world. It just wraps it up so that you've got a controlled piece of code. It's extremely useful. For education, this is ideal. Let's go back to Blockly, the Blockly workspace tab. Excellent, there we go. So now I can open the README. I can then go to my examples at speed. I've got a logic demo, which is essentially, it's going to print hello on the LCD, but this is just showing you how to do a for next loop inside of a do loop. So for next loop, it's got some logic. If a number is less than, the for next loop is 0 to 255. And only when the loop variable is equal to 10 will it call the subroutine. And the subroutine is defined on the right-hand side. This is the state of development of Blockly. It's extremely clever. It seems to work well. I've been kicking the tires and found no major issues in it. So with that, I'll go back to my PowerPoint and we'll call that a wrap. Enjoy.